This is block 4 from topic 1, using ratios. The first thing I want you to do, you have graph paper in front of you, is draw a small rectangle near the top somewhere. It can be any size, but relatively small. Any size rectangle on your graph paper. Now we're going to scale that rectangle by 2 and draw the new rectangle. So if I scaled it by 2, what am I doing to the dimensions? It is increasing how by 2? I'm multiplying each side by 2. So draw your new rectangle. So you need to figure out what your side length of your original was. Multiply those dimensions by 2. Now record all the side lengths of both rectangles. I don't have graph paper, but I have my sketch there. When I scaled my rectangle by 2, what happened to the side lengths?
Each of them increased by, each of them increased twice as large.
Twice as large, meaning multiplied by 2. What do you think happened to the area? The area is how many squares you have inside your box. You can't really see the area of mine, but count your squares in your small one, and then count your total squares in your large one, and write them down. So my small one had 6 squares. My large one had 24. Is there a pattern that's happening with the area? Yes, sir. It multiplied by 4. Did all of yours multiply by 4?
Yes.
All right. Mine also multiplied by 4. What was someone else's small area of a rectangle? What was your area? 2. Oh, a 2 by, what was the area of it? So
The area is
10. So yours went to 40. Interesting. All right. Well, going back here. Let's see what's happening to this flower picture. Right now it has a scale factor of a 1 and an area of a 1. They doubled the picture and the area quadrupled. They tripled the picture size. And the area increased to a 9. So how did I multiply by 4 on this one to get my new area? To get it 3 times as large? No. How would I, do you see a pattern? What you see? Okay. So like if this double picture here, the scale factor was 2, you're saying if I go 2 times 2, I should get the area of 4. On the tripled one, what am I multiplying? 3 times 3, does that give my area? So if I was quadrupling the picture, the scale factor would be a 4. What would the area be? 16, because 4 times 4 is 16. Alright, very good. So, we're looking at problem 1A in your textbook. It says, you have seen how the measures of the sides of a figure change when you scale a shape. Consider what happens to the area. It says, how did the area of the shape change when the dimensions of the shape doubled? What did the area turn to when it was doubled? 4. So it changed by a factor of 4. So on 1A, we're going to write the area changed by a factor of 4. The area changed by a factor of 4. What does factor mean? What operation does that normally mean? Multiplication. So it was multiplied by 4. B says, how did the area change when the dimensions increased by a scale factor of 3? So what kind of factor happened on this scale factor of 3? It was a factor of 9. It got multiplied times 9. Because 1 times 9 gave me the new area of a 9. So 1B, the area changed by a factor of 9. 1B. Okay, I'm on problem number 2. There it is. Alright, so I have a 1 unit. 1 unit is like a unit is like one of these little squares. That's what unit means. So 1 unit is how long this side of that triangle is. And this is following along with your textbook on number 2. It says each side of the small triangle is 1 unit long. How does the side length of the small triangle compare to the side length of the larger triangle? How many side lengths do you think it's going to take for this larger triangle? 2. You think 2. So if I take this, and I'll be a touch screen with this. So yeah, it looks like it's right on 2 if I put it there. So, the side length of the large triangle is blank times as long as the side length of the small triangle. How many? 2 times. So, you're writing that for answer 2A. The side length of the large triangle is 2 times as long as the side of a small triangle. Anyone still writing this? Okay, now we're going to look at area. How many of these 1 unit triangles do you think can fit in my larger triangle? Yes, ma'am. 4. She thinks 4. Let me grab them and see. We'll put 1 right here. 1 right there. 1 right there. This one I've got to turn upside down if it will turn. I agree, there are 4. So the area of the large triangle is blank times the area of the small triangle. What is it? 4. 4 times. So you can write 4 times the area of the small triangle. 4 times the area of the small triangle. Anyone still writing? All right. Moving right along. So, a linear scale factor is used to enlarge the small triangle. Linear means a straight line. Hence the word, isn't line in the word? So linear is a straight line. So linear is talking about edges. What happened to my edges, edge lengths? I went from a 1 to a 2. So what did it increase by? It went up by a factor of 2. That is a linear scale factor. So my linear scale factor is a 2. I had to multiply 1 times 2 to get the new side length. Then I have an area scale factor. My area went from a 1 to what was my area? 4 triangles. So it went to a 1 to a 4. So what is my scale factor of the area? 4. So I have the same shape, but 2 different answers. If I'm looking at a linear, just the length of it, that's a linear scale factor. If I'm looking at the whole object, that's an area scale factor. So my scale factor of the linear was 2, the area was 4. Oh, is it making me write all that stuff? I was thinking on the forms. All right, in 2D, they want to know when I was going from these little ones to the big one, what was my linear scale factor? When I went from the small triangle to the large triangle, what was my linear one? Say 2. Okay? But if I'm going from the big to the small, what am I having to do? Divide by what? 2. But the definition of scale factor says a number you multiply by to enlarge or reduce an object. So it says in the definition for scale factor, you have to multiply. But we know we're having to divide by 2 to get there. So what can I multiply by that will be the same as dividing by 2? What? 0.5, or how else could I say that? 1/2. So if I'm going from the large triangle to the small one, and to get smaller, it has to be less than 1. My computer will only let me type decimals. So 0.5 would be my linear scale factor, or how do I write that as a fraction? 1/2. I would write that off to the side here, because it could be a fraction of a 1/2. Okay, area-wise, when I went from the small to the large, what was my scale factor? 4. Now I'm going from the large triangle to the small. So if I'm shrinking an object, it has to be less than 1. So it has to be a fraction or a decimal. I really need to divide by what? 4. But the definition of scale factor says to multiply by a number. So what can I multiply by that's the same as dividing by 4? What you got?
1/4 or 0.25.
1/4 or 0.25. If I had the number 4 and I divided by 4, that gives me 1, right? 4 times 1/4. 4 times 1 is 4. Divided by 4 is 1. That is the same thing. So, 0.25 or 1/4. That's what we're going from larger to smaller. All right, so let's get 2 sticky notes to recap linear scale factor and area scale factor. Okay, it says scale factor. Linear scale factor is that. And it has 2 sections. The first section says to find. That's when I need to find the linear scale factor. And notice how I was being lazy. I wrote LSF. What does that stand for? Linear scale factor. I was just being lazy. If you know what LSF will stand for, you can be lazy too. Math people like being lazy to come up. That's what math is, a shortcut. So to find linear scale factor, we have to take our new and divide it by our original. If I was given a linear scale factor, I would use that and multiply it by my original to get my new. That's all on one sticky note. I go to the next one. This is the second sticky note is area scale factor.
Miss Adam,
Yep.
just need to call Clark here in the office for a minute.
Okay. So I was being lazy again, and what did I use for area scale factor? ASF. And to find the area scale factor, you multiply your linear scale factor times itself, and it will give you your area scale factor. If they give you the area scale factor, you might need to use it to find the linear scale factor. To do so, you have to ask yourself what number can multiply by itself will give you the area. Probably doesn't make much sense right now, but we will use that sticky note in just a second. Alright, so your homework assignment says to do problems 3 through 7. But when I looked at some of the homework problems, I had to sit and think about it for a second. So I'm going to get you started on a couple problems. So the first problem I'm going to look at is number 3. And they have defined for you linear scale factor and area scale factor. You might want to take a minute and highlight that so you can see. You have highlighters in your basket. Linear scale factor and area scale factor. So, what they wanted us to do was to find a linear scale factor for the, I have an image on the left, and they made a new image on the right. They kind of look similar, except it was larger. They want me to find the linear scale factor and then the area scale factor. Linear is dealing with the line. But do any of these lines of this diamond fall on the lines of the grid? Okay, this line here looks like it's 2, but it's really not. You can't measure something that's going through a diagonal. So it's really not 2. You have to measure using the line. So the only way I can measure this diamond is going across. I see it go is 2, And then in the new image, it is 4. Do that with your diamond. Went from a 2 to a 4. Well, my sticky note that I just wrote, where it talked about linear scale factor, says I need to take the new and divide it by the what? Original. So my new is 4. My original is 2. So what is my linear scale factor? 2. Okay, I answered part of the question. Now the area scale factor. How on my sticky note did it say to find area scale factor? What did it say? Okay, multiply the linear scale factor by itself. So what was my linear scale factor? 2. And I'm going to multiply it by itself. So what is my area scale factor? 4. Okay. There are my 2 answers for that problem. You would do the same thing with the triangle, but at this time, do I have a line that's on the grid lines? Yeah. So I would actually use one of these lines. This is 1, 2, 3, 4, 5, 6. This goes 1, 2, 9. Then I would do the same thing. Then I would do the same thing with the rhombus down below. Okay, so I got you started on number 3. I want to look at problem 6 next. Okay. 6 says, Kiana's boss asked her to enlarge a house floor plan by a factor of 4. Kiana is not sure if her boss meant to enlarge the floor plan by a linear scale factor of 4 or an area scale factor of 4. So she decided to do both just in case. So A, we're going to do a linear scale factor of 4. Well, what is the dimension, what is the straight lines of my floor plan? 4.5 and 6.2. Well, if I increase it by a scale factor of 4, what do I do to both of those? Multiply both of them by 4. That gives me, what, 18 to 24.8. So my new dimensions could be 18 by 24.8. That part was real simple. I didn't have trouble with that part. It was part B I had to think about for a minute. So we're good on how we found A. That's what we've been doing. How did I find, they told me a scale factor of 4. Okay. B says, what are the new dimensions of the floor plan if we did an area scale factor of 4? So I was like, I have no idea where to even start. An area scale factor, I need to know what a linear scale factor would be of that. So look back at your sticky note for area scale factor. That little paragraph you wrote says, if you are given an area scale factor, was I given an area scale factor? Really?
Yeah.
They said it was 4. Okay, I was given. Says you might need to use it to find the linear scale factor. To do so, ask yourself what number can be multiplied by itself that will give you the area scale factor. So what was the area scale factor they gave me?
4.
4. I need to ask myself what number can multiply by itself to get 4. Produce 4. 2. So that means my linear scale factor is 2. Why do I need a linear scale factor? Because they wanted to know the dimensions. The dimensions are linear. Are they area? No. They're linear. They're just straight lines. So now that I have a linear scale factor, I can find the dimensions. So I would do, I'm out of space down here, so I'm coming up here. 4.5 by the 6.2 times 2 this time to get my new dimensions. So what would my dimensions be of that? 9 by 12.4. Okay, the other homework problems you should be able to figure out. So I got you started on several of them. I'm checking 3 through 7 tomorrow. Thanks for watching. Subscribe.